Hello, everyone, and welcome to today's webinar, An Introduction to Cloud-Native Product Development. My name is Alex Janicki, Director of Marketing for TriStar, and I'm excited to be your moderator today. I'm pleased to introduce today's speaker. You should be able to see him, Mike LaFleche. He's Channel Technical Services Manager for Onshape. Today, he's going to be giving an overview of Onshape and how it helps businesses modernize their product design process, followed with a live demonstration. You all should notice we've included an ebook that goes into a bit more detail that you can kind of take away, and that can be found in the handouts tab. Finally, we're going to be answering questions at the end of the session, and you can simply leave them in the Q&A section, and we will answer them afterwards. If we don't get to your questions during today's webinar, feel free to reach out to us at any time afterwards, or visit the Onshape product section on tristar.com for further information, as well as information on pricing and how to receive a 14-day free trial. Really, without any further ado, I'd like to kick things off by welcoming Mike from Onshape. Mike, I'll pass it over to you.
Thank you very, very much. I appreciate the great intro, and it's a pleasure to meet you all today. Little background on myself. I am an Onshaper. I've been at Onshape for 5 years, and we were lucky enough to be acquired by PTC. About 6 months ago now. Time has really flown. Before I worked at Onshape, I was actually a SolidWorks value-added reseller for 15 years. So I have a great understanding of what users have gone through. Many of the people at Onshape are actually former PTC people that have come back, or SolidWorks people. And we really saw some interesting challenges in the last few years with product development that we knew we could solve by implementing a more modern architecture for CAD and PLM by hosting it in a cloud-based platform in a proper software as a service type solution. So today I'll walk you through some of the challenges that we uncovered when working with a lot of users of CAD, whether they be from SolidWorks or Inventor or other install-based CAD systems. And then we'll discuss the Onshape solution, and then obviously give you a nice demonstration of it live. I'm just here working at my home office today, just like I'm sure a lot of you are as well. So it's really cool to be able to see how Onshape can work on any device from any location, anytime. So let's just go full screen here and turn off these notification messages that are plaguing me. Just 1 second. Kill that app. Thought I had done that earlier. Okay, great. I will reshare my screen. Alex, you can see my screen again, right? I would imagine so. So let me go full screen. There we are. So let's get into some of those product development challenges that we heard from the many, many thousands of customers that we've talked to over the years. And if we look at this whiteboard, right? Let's whiteboard this out. These are the challenges that we've seen from our customers over the years, when we used to be at SolidWorks and other CAD systems. Let's look at these 4 people. We have 4 people. They are working for your company. They might be part of your supply chain. It might be a sheet metal shop that you're working with. You might be doing a design of a sheet metal product and you're sending it out to a sheet metal shop to be manufactured. This could be a distributed team. You might have people in New Jersey versus California doing work together. So there were some impediments to getting products designed fast in an innovative way without losing the history of the information, and trying to be as efficient as possible. So these are all the aspirational things that any company would want, right? But if you look at this dotted line, if we draw a dotted line across the whiteboard here, what gets in the way of speed, innovation, and efficiency? Well, the first thing that you should think of is install CAD tools. If you really think about it, and you really have to kind of dig down and think for a second, but how would an install-based CAD system get in the way of speed, innovation, and efficiency? Well, let's say you guys have an installation of your current favorite CAD system. Let's call it SolidWorks for lack of a better one to think of. You install that software on a person's computer. That can be, of course, installed to many different users around your company. If you're a larger company, you're installing PDM software as well to manage the revision control, and that's a separate piece of software that you install on top of it. Furthermore, you install server-based software to manage the PDM, and you install server-based license code servers to distribute access and licensing to that information. And then on top of that, to access this, especially in a situation now where we're working remotely quite a bit, you have to VPN in, you have to use FTP servers, you have to use network drives. For people on the outside of the CAD environment, they're installing viewers. And what leads to issues is the software version mismatch. So if you're on one version of the software and you want to share with somebody else with a previous version of the software, you're out of luck, right? You're gonna not be able to share that information. You'll end up exporting it to another file format, PDF. Then you're asking yourself, the next question, what is the latest copy of the file that I'm sharing? So on top of a copy of a CAD system that you have to worry about, you have to worry about copies of CAD files flying around in various ways, right? So people share, of course, by email, by thumb drive. Let's hope not, because that's a huge security risk. By cloud-connected systems like Google Drive or OneDrive. So these create copies. Every time you send somebody a file, you're sending a copy of a file. You're not granting permission to the file that you want them to work on or look at. You're sending them a copy. And that immediately raises red flags as to if you are working on the latest version of that copy of a file. Am I overwriting somebody else's work if you're working in a network drive type system? A lot of people will invest in a PDM system to prevent that from happening, right? And what a PDM system will end up doing, a file server will let you kind of go in and get access to the file you're looking for, only one person at a time, of course, based on the rules of Microsoft Windows and any other file system. People will buy a PDM system to check out the file, so nobody else can accidentally work on it. They're getting permission to work on it, and they check it out and check it in, so only one person at a time can work. But even a PDM system creates a whole bunch of file copies over and over and over again. Every time you go to Rev A to Rev B to Rev C, creating massive amounts of data storage on locally installed servers that you, as a customer, have to maintain. Right? The attack area of this is insane, right? All the copies of files that can be accessed and accidentally used is awesome. I'm awestruck at the amount of copies of files that float around when talking to customers, even if they're using a PDM system. And people have tried to solve this by putting files in the cloud, but that just moves the problem to the cloud, right? Even when you're using Google Drive, you're not operating on a file outside of the Google Drive. You're actually operating on a copy that's synchronizing to your local computer. So it still really doesn't solve this, and it really causes a serial design process to occur. Only one person at a time can work on a file. They pass the baton from one person to the other to get the work done. That's all we've known. But if you think about it, other systems have adopted more parallel workflows in the last few years, haven't they? Look at Google Docs, look at even Office 365. You can be in the same spreadsheet at the same time doing work with each other without checking in and checking out a file. So we were inspired by this type of workflow when we developed Onshape, which is a unified cloud solution, a platform for product development, for, of course, the design of CAD geometries, right? Parts, assemblies, drawings. I'll just click into this cloud here so we can see some of the things that you would expect to see in any CAD system worth its salt, right? If you're coming from any parametric Windows-based system, these are things that you're going to want: parts, assemblies, drawings, the ability to configure variant designs, having access to standard content libraries. But we didn't stop there. We decided to improve the workflows in some areas where possible, right? So we have this thing called multi-part modeling, managed in context design, and simultaneous sheet metal as new ways of getting the job done faster and easier. And we'll show that during today's demonstration. We also developed a custom feature language called FeatureScript, which I'll talk about in a little detail as well. But CAD is not the foundation of it. The foundation of this is the database-driven approach. No files going back and forth. Everybody's working on a central access point to the system, and I'll discuss the architecture of that as we get into the demonstration. And what this really allows for is for very interesting ways of doing data management that were just not possible before. And we were inspired by the way software development companies have been doing their code and version control, like things like GitHub, for example. They allow you to branch off and try out different ideas, and then you merge the code back in later, at a certain point after a design review or a peer review. So Onshape, inspired by that, built our data management system to kind of mimic that way of working. The ability to have version control at all points in time, compare and contrast, and merge design ideas forward at any point in time. So these are things you'll see in today's demonstration that improve your productivity and reduce the amount of files being created all the time. So I'm not going to talk anymore on the slide. I'm going to talk about the features, as I'm demonstrating the Onshape product here for about 25, 30 minutes, 40 minutes maybe. And we'll leave some time for questions at the end, because I'm sure everybody is going to have a ton of questions about what this all means, how to get started, and what are some of the best ways of moving from your previous system to a system like Onshape, because it is a little different. You'll see it. It's similar in some ways, but different in many other ways, and hopefully the good ways, right? So the things that I want you to think about as we're doing this demonstration are these 6 items, right? And let's go from the bottom up. There is 0 IT tax. You're not installing a thing when you're running Onshape. You're not installing servers, clients, PDM, nothing like that. No backups to worry about. Everything's taken care of. You're going to find it very easy to share your product knowledge with other stakeholders within and outside of your organization. And at the same time, having a full release management system that allows you to do PLM capabilities for revision control purposes. We'll show you some of the different ways we've decided to author parts and assemblies that are very fast and very effective, and we'll talk about the real-time nature of the system. So let's just get right into it. You can see that I'm on a MacBook computer, and I have my phone here, my web browser Chrome here as one user, as Mike the manager, and I have another Chrome user over here for Debbie the designer. And this is a native Mac. There's no boot camp or anything like that. I'm running this just natively on my 16-inch MacBook Pro, which I recently acquired, but this will work on any device. Windows workstations, of course, Chromebook. All your kids are going to school and they're using Chromebooks now. Chromebooks are fantastic devices for because there are no files with a Chromebook, right? You're just accessing information that you're shared into. Onshape works on that, on the phone, Android devices, you name it, right? So to use Onshape, I simply just go to another tab in my browser. That's it, right? And I have something that shows me who I've signed in as. I've signed in as Mike the manager in a company called SAAS Systems, a fictitious company that I've made up here for the purpose of this demonstration. You can see all the documents that I have here, libraries, folders, things that you might be shared into. So like here's the commercial items folder, and in here you can see all the people who are shared into that right here. If I want to look at something, here I have a small piece of machinery that will design a portion of here today, with all this stuff, moving back and forth. I have some advanced mates and mechanisms to, put this thing together. So we'll finish that off in a demonstration. We have configured product design, where we can have several variants of the same thing. You can see a long configuration of this conveyor and a short configuration of this conveyor, and these are very easily generated. These can then report up to very large systems. So here's the whole factory layout. A lot of people, when they think of a cloud-based system, they're scared at first because they're thinking to themselves, how can it possibly be fast? How can you possibly do design work with a web browser in the cloud? Isn't it going to be slow? The answer is no. And the reason why the answer is no is because we're taking a different approach. A lot of people, accessing CAD systems from home would like remote into the office and drive their workstation remotely through like a meeting like this, a GoToMeeting or Citrix WebEx, whatever it is, remote PC stuff. That's awful. Like you see it streaming and pixelating. That's just not a pleasant experience. Onshape is actually rendering all these graphics locally on your computer using the power of your whatever your desktop or mobile device graphics chipset you have. I happen to have a MacBook Pro with a photography editing graphics card. I'm a photographer, so that's why I wanted a MacBook Pro, right? And here, that's all I'm using. I'm not using a special setup. I'm just using Chrome with my MacBook. And when I spin the model around, you can see it's spinning like a top very quickly and easily because it's the power of WebGL in your browser that renders this, right? So this is just free, comes with the ride for being in a browser. When I'm opening this design, though, it's opening this on extremely powerful Amazon data centers. AWS is a huge web services company, powered by Amazon, right? And we use all of their servers globally in a secure way to host your information and the CAD system. So the information lives there and is never copied to your computer when you're working. So that is really the reason why you can open up massive things very quickly and interact with them. Of course, it's a CAD system that lets you create parts, assemblies, and drawings. Here's an assembly that we're going to build right here, and it has the the mechanism design, a bill of materials at the assembly level, ways to configure it. You obviously have the ability to create detailed blueprints and drawings for these designs right here. So here's a proper drawing with a whole table and all the tolerances that you would expect to see for a product design. So know that we can do all that. Let's actually get right into it. Let's I'll save the beer for later. Hold on. All right, so let's go over here, and kind of early in the morning for a beer. I don't know why I brought that up. But anyway, so let's go in and build something. I have the beginning of this machine kind of built up here, so I don't have to draw every single line here for you in front of you live. But this should look familiar. It should look like a parametric feature-based CAD system at this point. You open a thing called a document. A document can create parts, assemblies, and drawings within it. You don't need to know how many parts, assemblies, or drawings you need up front when you create a design in Onshape. So here I have a layout sketch, parametric, of course, showing me different different pieces that I might want to design in a napkin sketch-based way, right? So I can very easily and quickly build out shapes that I'm looking for. Then I want to make 3D models from that sketch, and I have all of the normal parametric tools that you're used to seeing. Here I have an extrude. You notice the ribbon of tools is very Spartan, right? It's because the tools themselves are very deep. Solid and surface modeling. You can create new parts. You can add the parts, cut, even create Boolean intersections at the same time with one fantastic tool. But of course, all the end conditions, all of this will be very familiar. You will feel comfortable when starting in the Onshape system this way. Now, the depth of this, I'm going to say it's 2 times the plate thickness. I have a plate thickness variable in my tree, as you can see right there, and I'm going to use that variable. Of course, I can just type in a number if I wanted. So there's part 1. Onshape generated a part in this parts list that it's managing. So if I were to keep on modeling, I would hit extrude again and extrude up to maybe this vertex point or a face as a new part. You can see as I do that, it highlights part 2 being created. I did not have to go to C:\/ my documents / project X / part 2 to save it. Onshape is creating parts on the fly for me that are full first class parts that I can work with. So there's part 1 and part 2, and I can rename this part 2, and we'll call this the fixed plate. That's essentially the quote unquote file save operation, but there really aren't files, and I'll get into that as we keep on going. I'm going to call this the rail right here. So I've created 2 parts all together in the context of one another in a single part studio without creating assembly relationships or anything. It's fast, easy to do. So we have that in place, and I want to share this design with somebody else, right? So I'm just going to turn off all these sketches, and I want to add a comment to one of these surfaces right here. I'm just going to pick that surface and add a comment, much like you would in Google Docs, for example. You would just @ somebody into it. I'm going to say, hey, Debbie, can you recommend how to attach this to the base? And of course, we're in a browser. We have spell check. Not a grammar check, though. Let me just fix that. How to attach. There we are. And I can assign that as a task, a simple task for Debbie to engage with, right? Instead of like trying to keep track of design tasks by email or Gantt chart or whatever, you're just letting Onshape take care of that relating to this surface that I've selected and assigning that to Debbie. So everything's a name in the system. Like I've signed in as Mike, the manager, and I've assigned a work order for Debbie to work on this surface. So let's go in as Debbie. I'll go over here. Here's Debbie, the designer, and she's going to sign into her Onshape account. Remember, all she has to do is go to a browser, sign in to Onshape, put in her email address and password, and she is in the system. And the first thing that she sees is an activity feed. And in her activity feed, she can see that comment and everything else she has access to, right? So she can say, sure, socketed cap screw. And she could reply in line in the comment feed, much like you would in a social media type application, right? So it's a very fun way of interacting. There's other ways too, like the action item bin. I'll sort it on newest first, and I can see the comment in here. So this is a running list of all the things that I am assigned to that I need to work on as Debbie in this case. So I'll view that comment direct from the action item list. And we're both looking at the same model at the same time, right? So this should be the first moment where you say, wow, what is going on here? This is different now, right? Because we have 2 people literally looking at the same exact information at once. It is not a file copy. I can actually see, that Debbie and Mike are both in the same document. I see a photo of Mike inside of Debbie's window, and I can reply to him and do all that stuff and see what Mike was looking at right by clicking that. I can even see Mike's point of view. If I double click on his photo, it will put me into the follow mode, and I can have a design review with Debbie live inside of the document to see what's going on. And then Debbie can take her viewpoint back at any time. It's almost like Star Wars with the holographic message of Princess Leia, and we're both looking at the same thing just from 2 different points of view. Kind of the only analogy I can think of that's on par with this. So now, as Mike makes changes, or Debbie makes changes, she doesn't have rights right now to do that, but Mike might make a change to make this plate thickness, bigger, right? So he makes that change, and Debbie sees that happen instantaneously, right? So very quick and easy to see changes pop up. I can even upgrade Debbie's permissions at any time. So right now, Mike has edit rights and engineers in a group have view and comment rights, but I'll also upgrade Debbie individually so she can edit this design alongside me. And I will focus in on these permissions, and these permissions are not things that you can get in a file-based system of any kind. This should look like a familiar screen though if you've used any modern file sharing apps like Google Drive and things, where you can set who can do what with documents in the cloud. So this is very similar, right? I'll give Debbie edit and comment, but she cannot share it export it, link to use it in other designs, or make copies of it. Simply not possible with any file-based CAD system, of course. So now Debbie can just refresh her browser, and her CAD viewer will become a CAD system. You see the toolbars are now here, and now Debbie can go in and show Mike where those socketed cap screws should be, right? So I'll just create a rectangle with a couple of parametric dimensions here. We'll say that's 1/2 inch here, and this is 1/2 inch here, and I'll just make this symmetrical about the plane that's cutting through here. You know, you have all the relations and all that like you would expect. Let me just do it back here too. All right, so we have this rectangle for some holes to be placed, and now I can just start typing in commands, so that way I don't have to hunt them down. I know I want to put a hole in, and I want the hole to be on that sketch, and I want it to be a counterbore for a socketed cap screw, M5 or whatever it is, through the part. And of course, Mike sees that happening instantaneously. He likes that idea, and he's going to go in on this side and place, a couple more holes, on here. Maybe just splitting this in two, or putting in a point in the middle, and he can just place those holes as well, or even use the existing hole right here, just to edit that and add more vertex points to the holes on a completely different part in the same feature, which of course is impossible with any other file-based CAD system to do as well, having features that cross parts. This is a part studio, it's not an assembly, I just happen to be designing these parts together. Now this whole time, it's been maintaining version control for me. You did not see me ever hit the Control S button on my keyboard, right, to do a file save as operation. Not a thing you have to worry about in Onshape. Everything is just continuously saved. What does this mean? It means you will never ever lose work again. It's a bold statement, right? But you just won't, because every single operation is recorded in the history of the design. You can even see who did what and when. Mike did that, Mike did this, Debbie did that, 11:27 a.m. Boston time, where I happen to be, and there it is, right? There's no doubt as to who did what. We can even label versions in time. So here we are at version 1 for some informal version control in the design. And then from here, I can even branch to create new and different ideas that are in a sandbox of my own. So I'm going to do some design for manufacturability on one branch, and maybe Debbie is going to branch off for the more part design, right? And maybe Mike will do the part design and Debbie will do design for manufacturability, right? So we can work on these different branches in the same document, but in different workspaces, right? So let's do that. So now Debbie, or Mike, will go in and create new parts. He's going to turn on the sketch for the base station there, and he's going to create another part, extruding that up to a face, maybe right here, and we'll tell it to be a new part and call that part, let's call it the moving plate. There we are. Now, all this time, I can actually go in and get information about the parts. We have all these tables on the side that you can turn on. So I can add a table for perhaps keeping track of all the part masses. So this is part of our feature script functionality, but you can see I have the parts and they have unknown mass and material. Let's set them all as a certain material. We'll say it's 303 stainless steel or 300 series. Let me just see what I have. We'll go here, I guess. But as soon as I do that, the table updates, and as I start updating the part design, if I change this plate thickness value to 1/2 inch again, you can see all these values are here. I don't want this to be more than 7 or 8 pounds, but if I was over at 1 inch plate thickness, you're seeing I'm up to 15 pounds for all these parts put together. So these really quick, easy ways of learning about information are here in the system. Let me undo that. Control Z, and of course all of that is being kept track of, in the history of branch 2. So I like the way that's going. I can create versions here. I can even start to create detailed drawings while I'm in here. And I want to create a drawing right away of that part because I know that I need to get this part out to manufacturing right away. I need to stamp it for approval at Rev A and get it sent out to a machine shop on the outside. So of course I have my drawing right here. You can obviously go in and create all the types of views that you would expect, to see in a detailed blueprint. I'll put a whole chart on here with this is the origin. That looks nice right about here, perhaps. Move this over and just add a couple of reference dimensions with tolerances. You saw the other drawing with all the geometric tolerancing and all that, right? So I won't go too far into that. But what I really want to make sure you see is how to approve this design. All right, so this drawing is inside of this document on this branch right here, and I can create a release package right from here using a workflow of my choice, right? So I have an agile non-project based design workflow, but if this was like some fancy product and I wanted to go through all of these different other approval processes, I could do that as well. For the sake of time here today, I'll just do a simple workflow, and this is built in the Onshape, right? If you're a professional or enterprise user of the system. And I can see there's the fixed plate, and there is the drawing of the fixed plate. So it collects that information. I can establish an automatic part number. We have a generator in the system to do that. And I can say that this is a drawing of that part number being released under an engineering change order of the same number to my engineering team, which happens to consist of these people. And I'm going to hit that apply button. But before I do that, let me bring up my phone. So I'm going to bring up my phone. Let me make this a little smaller here. You can see this is my real life phone, okay? And I can actually click Onshape on my phone. I got to look at it to sign in because it's Face ID, only CAD system Face ID from what I understand. And I can, get Onshape on my phone here. And this is Ed, the engineer, on his phone. He's on site with a customer, all right? So I'm going to say, please review. And I'll submit it to peer review. And as soon as I do that, anybody who is a member of that team of people is going to get a notification on their screen. And you can see there it is, release ECO 2562A requires your approval. And at the same time, over here, we can see a special event happening, a little triangle showing up saying that there's a pending review stage right here. Now, I'm going to click on my phone that ECO and approve it. Of course, I could have looked at it first before approving it, but I have a PLM system in my pocket. Okay, that's what that just was. And you see how quick this updated. Ed could be on the other side of the world and it would be just as fast. We even updated the rev table, right in here automatically. So already approved in the design right here. And the next rev would be A1 if we were to continue. And I want to use that approved Rev A part in the assembly to put all this stuff together. So I'm going to do that on this tab over here, inserting the three parts that I have here so far, the moving plate and the rail, which are works in progress, and then the released Rev A part that I'm sending out for quote to get machined. And you can see you have proper configuration control at all times in the system. There's the Rev history, Rev A. I can view that release package anytime, see that Ed was the person to release it. All of it is here in the history of the product. Now, Debbie, on her side, let me just hide the phone. There we are. Debbie is doing some design for manufacturability. She knows that this plate thickness, really should be 1/2 inch. She is going to change the width, of this to be something different. And we will say that this is 8 inches now instead. So she's making a whole bunch of changes that are different than what Mike just released, right? But that's okay. It's non-blocking release management. We can work on different branches, understand the differences between these designs, and now you can see right here, there's an additional part. The parts are different thickness. I even have a list of all the changes right here. And I can decide if I want to pull that in from Debbie's place, right? So all the stuff that Debbie did is on top here because that was the latest edit. And I'm going to take the release DCO and the design for manufacturability ideas that Debbie had and merge them together. So I just merge this and I merge that. It merges everything in the document as well. Let's go to the Part Studio. And now we can see the best of both worlds. We have both parts, or all three parts, and the changes that Debbie made are all in here. And of course, I would need to do another ECO to send that out again and pull the other one from production. But that's all part of PLM strategy and process within the system. Even the drawing is here, and the drawing can be updated, of course, with the new information, and we'll see everything update accordingly. All right, let's go back to the assembly. Let me just insert this assembly again with all three parts work in progress this time. I'm going to fix the fixed part in space, and I'm going to put this together to mate it together and add some standard library parts from my old CAD system as well as stuff that I have in Onshape. So I want to mate all of this stuff together. So I have these three parts right now that are not mated in an assembly. So this was a part studio we were doing work in, just three parts designed at once, right? But in the assembly, we're actually defining relationships, the number of parts, and you tell it how it's put together. So I just pick those two corners and say, hey, you guys line up. Maybe we'll have another instance of this part, copy, paste it. Now it's instance 2 of the rail. Of course, the bill of materials is updating to show us all of this in the table view in the assembly. To put this together again, let me show you how easy that was. You just pick this corner, pick that corner, and it's fully mated. We call these mate connectors. They're just very easy to put parts together. You don't need to look for planes or axes or put 3 mates on per part. It's just continuously, looking for geometric places to mate to. I could even do things like a slider mate. I want to have this right here about the midpoint slide against this midpoint. And I could even provide limits on all of the mates, right? So I'm going to say, I want this to be a 4-inch kind of travel back and forth right here. And it's already letting me move that around. 3 mates, 4 parts in the assembly, right? So very quick and easy to achieve. And of course, we're seeing the bill of materials update with all the parts. I can insert other parts from this document or from other documents that I can browse into my own personal library that I've built. So I have some commercial items that I could place in here, of course. Like if I was looking for an assembly and I knew that it was made by a certain supplier like Bueller Motor Company, I could just do a search for that in the system. And it shows me there's a released part that I can use right here, Rev C of that, and I can place that in here and just move it from here to here or whatever. Not that that's really a good one to use, but you can see it's there. All the mates will solve right through, so it lets the motor spin. Pretty easy to do that. And then finally, I want to insert something from my library of standard content parts. Onshape provides a toolbox of fasteners for all the different global standards. So I can say I want a socket head cap screw, as Debbie recommended, and I can put it in for the shape right here. I forget which hole size I needed, so I'll just interrogate it by using this auto size button. And it will tell me if it finds a size that matches. It doesn't, because I think I used a metric screw, right? So let me go to metric and do that one instead. That is better. Now if I pick that, it will tell me, oh, it's not telling me. I know I used an M5 though. I'll just keep on plugging away here. So there, I'll just go in and place those in here, and very quickly I can place that hardware. In fact, I can just pick one, hit the insert button, and then replicate all of those all over the place. So here's replicate. And I can say, look to put one here, here, and here. There's obviously many different ways you can do this. I'm just picking what just came to mind offhand right now while I'm in full-on demo mode, stream of consciousness. So, all right, just turning off those symbols. So now we have a fully mated thing. We have all our parts showing up. We'll do a structured BOM here showing us the motor and the hex head cap screw and the maturity state of that. So all of that is being created, but maybe I don't want this motor. I want a different motor that came from my current CAD system. So I'm going to import from my desktop. There's different ways of bringing in information in Onshape from your file system or from other cloud connected storage, but I'll import this hydraulic pump, a step file. It could be a SolidWorks file, Inventor, Creo, whatever file type you have, we can bring it in to Onshape, okay? So I'm bringing in a step file here of an assembly, and I'm gonna just import it. And I hit the import button on the back end. Onshape is doing this on all the different servers that Onshape is running on Amazon. It doesn't like lock your computer up when you do these things. And you can see now it added 2 new tabs to my document. I could have imported these into a separate document altogether, and I could even move these out later if I needed. But there's the assembly, a step file that I'd received from somebody using SolidWorks. They were running, so I just got that file, I have it, and now it's in Onshape as a document, as an assembly, and I'm gonna call this the hydraulic pump right here. Looks good to me, and then here are all the parts that make it up. Now, if I wanted to modify this part, I could actually switch right to this part, the front plate, just switch right to it, and I'll hide all the other parts right here because it just dumped them into one place. I'll just hide all the other parts because I dumped it all into one document. Like I said, there's many ways of doing this, but I can just take this and modify it by doing something like that, maybe picking multiple faces. Maybe I don't want that face. I want it to be wider by 1/2 inch. So even though we imported a step file, I was able to make modifications to it because it's got automatic geometric feature recognition. It's not feature recognition like finding the features of the original model. It's looking for geometric manufacturing features. Like I can say I'm looking for a group of holes. I pick that, and it sees that that's a counterbore hole, and I can find the patterns of them, add that to a selection set, and even modify, you know, the size of these holes pretty quickly, bigger, smaller. We'll make these 0.05 bigger. And just like that, we have the new parts, and of course that's updated the assembly just like that. I'll just add a mate to all the parts on the assembly, so when I insert it into my top level assembly, here's the base station of the hydraulic pump. I can drop that in now and of course just mate that, you know, into place. Or I'll actually replace this motor with a replacement in this document or another document, either way. And there it is. And of course, I would just need to refasten it to a different mate location. Something like that would work. And you can rotate it into place. And of course, see that there's interferences and all that in the design. Right. So that's how we would work in Onshape. That's kind of the workflow, right? You're going from a serial workflow to a parallel workflow in the Onshape system, right? That's the benefit of Onshape, is that you can get more done with more people at the same time, no matter where they are in the design process. It even lets you do things like configured designs, and I'm not going to have time to show you all of these things today, but you know, being able to very quickly and easily, you know, work with assemblies and parts and configure them with multiple parameters in a configurator-based way is just part of the Onshape system. You know, we have exploded views built into the system for sharing very easily with people on the outside. All you have to do is just share a link and say, hey, take a look at this, and you're going to be able to, you know, work on this design. In fact, I'm going to put it in the chat box for everybody to see if I can organize those panels. Doesn't look like I can, but maybe Alex can take that same link and share it with the rest of the people on the call so they can actually spin around the model and look at this. So that's really the story that I wanted to tell here today. all of these things are happening real time. You have information at your fingertips that you've never had before. This is an example of, all of the different people around the world using Onshape in my company, my fictitious company that I've set up. I can see, this chap here in the UK and my fellow here in Japan, all accessing the system, all things happening, who did what when, how long they worked on things, really information you just haven't been able to get in your current CAD environment. So with that said, what I'd like to do is try to open it up for questions in the system. Most people will see this and they'll want a demonstration of their own, which TriStar is happy to work with. I'm working closely with TriStar in the early days of the exciting Onshape plans that you're all looking at now. If you're interested, you can sign up for a trial. Just contact TriStar and they'll help you, get started with that. It's very easy to try it out if you wanted to, or to get a demonstration from a TriStar resource. We have built-in lots of different materials in the system. There's a learning center. There's tech support built into the system. So it's really a very easy program to get started with, especially in this time where you can't go off installing servers on your own. And you just, you want an account, you can have one in 5 minutes. Just let us know. I mean, that's really about it. So I'm going to open it up to questions. Are there any questions coming in from anybody? Let's see. There is a questions panel in the GoToMeeting or GoToWebinar software that you're welcome to use, or a chat box that is also available. A lot of questions that come up when I'm speaking to people for the first time in Onshape is, how do I get my data in, right? You saw that with that hydraulic pump. You can bring in lots of data at once. It doesn't have to be one part at a time or one assembly at a time. You can kind of just select a bunch at once and it will upload to the system. So most people will bring in their commercial off-the-shelf items. Like here I have folders for all of the different parts that I like to use over and over again. And these were just a library of parts that I imported from my past, right? And they're available in Onshape to use. So very quick and easy. Onshape is based on the Parasolid kernel, which is the same as many other CAD systems like SolidWorks or NX or Solid Edge use that kernel. So that means geometrically, when you bring in information, it's going to be the same. Go ahead.
It does look like we have a couple questions here, Mike.
Good.
So first one, and that was awesome. Thanks again for that overview.
My pleasure.
So the first question, does it have the ability to create like a customized UI? And adding to that, does Onshape provide a unique instance per user, or is it shared?
Right.
Like how are the customizations managed?
That's a great question. So Onshape is a public cloud, meaning everybody gets their own unique company within the system, but it's managed as a true software as a service shared cloud. It's we're not like going to the Amazon data center and like putting a computer in place for each customer, right? That's just not the modern way of doing it. So it's a shared cloud, but everybody's information is shared securely at a company level, right? So this is like my company here called SAASify Systems, and these are the users in my system, and these are the preferences and release management customizations that I've set up for my company, right? So everything is segmented properly with huge amounts of security, much more security than many local kind of installed based software could even think of having, of course. We're piggybacking on a lot of the security that Amazon provides, right? And they're really good at it. Customizations are all at a company level. You can also customize the CAD system itself, as I mentioned, with that feature script functionality. So if I were to just Go to Onshape Premier Custom Built. Is a good custom customer story that uses our feature script functionality. So these guys are in Pennsylvania. They make custom cabinet designs, like extremely exquisite cabinets, right? And they use the Onshape feature script functionality. Instead of drawing lines and arcs to create each and every cabinet, they create cabinets based on what their shop floor needs are. In this case, you can see instead of a create feature protrusion feature, they have a feature called partition. And they've even put an icon up in their tree for this. And you can see that they can very quickly and easily build things based on what they can manufacture. So companies are using this for huge, advantage, right, over their competition, because they can quickly just build things that they can make with standards. The IP, the intellectual property, stays within the company and is only shared within the company. So they're able to just get things done very quick. We have other companies like Garrett turbochargers. You'll find their turbochargers in most automobiles that you drive today. They've done this to create turbo scrolls, right? Over and over again. So those are creating customized features using the Onshape programming language called FeatureScript. You can search that on the web and find all sorts of materials to help you get started with that. But of course, reach out to TriStar and us to help you with that.
The follow-up to that, which you basically just answered, so it does have like a knowledge base or a public API for that customization or automation.
Yeah. So there's FeatureScript, which is built into Onshape, and then there's an API that you can use if you want to drive other business systems outside of Onshape to connect, to it, right? So there's multiple methods of doing it. Day one, nobody starts playing around with the API. That's kind of crazy, but you can certainly graduate up to that, and it's a modern REST-based API, very secure.
Perfect. And then just kind of given the relative newness of Onshape, are there sort of any best practices that have been documented working with the tools and like sort of a proper change management to development environment?
Yeah. Everybody has a different process, of course. The Onshape, professional platform, and we've been selling this for 5 years now with the thousands of companies around the world. The Onshape professional platform provides some standard out-of-the-box workflows that are helpful to get started. And the Onshape enterprise platform is for customers who want to customize those workflows and do all sorts of different things. So most people start on the professional and then you'll graduate to the enterprise version if they want. But we have lots of learning materials built in to the Onshape system. So you can just go to onshape.com and look at the learning center. TriStar has materials as well if you go to TriStar's website, ebooks and things. But the video library and the learning center Onshape has is built in to the product. And you can look at self-paced courses and technical briefings, all linked up to your Onshape account, right? Meaning, if you want to figure out how to, what the best practices are for working with third parties with Onshape Enterprise, you would just start that article. It links to your user persona. It will keep track of the things that you've looked at, and there's lots of learning materials. And of course, tech support is built into the software. You just go to the help menu and say contact support, and it goes direct to Onshape's tech staff. And we don't have a lot of technical issues because it's not installed software, but we do have a staff of people that will field questions that are coming from people using the system very quickly and easily.
Perfect. And then really just to kind of piggyback off that one, just sort of a general question, because it is cloud-based, let's say you're working on something and you lose your internet connection.
Yeah, you wouldn't lose your data. You would just lose access to the CAD system for that moment where you've lost your internet. Now it's it's not going to be like, if you have a 2-second hiccup, it's not going to like hurt you. You're not going to lose access because it's just a quick timeout. Those things don't really, we're tolerant of those kind of things. But if you lose it for a while, you'll want to roll over to your phone and go to a hotspot or something if you want to continue working. You need some sort of internet, just regular, normal business class internet, 5 megabits or something or more. That's really the only requirement. Yeah, I've done designs on planes and hotel lobbies where the internet is awful and it works just fine. So business class internet.
And then we had several questions about the same thing. How does Onshape do when importing, exporting current CAD files as a Creo, CATIA? Like a lot of automotive customers, they will always want their specific versions.
Yeah, I mean, a lot of the automotive companies are going to gravitate to this type of functionality, of course, and already have. But we know in the meantime they're going to want to, give you native format files, CATIA, V5, NX, Creo, of course. So we can bring in the native formats, even CATIA, V4, V5, V6 in Onshape. No extra price or add-in for that. It's just part of the system. And you can import their native geometry, work on it, modify it if need be, use it to create your molds and other surfaces from it, and then export a file out, or better yet, share them directly into their design and blow their mind, right? Just say, hey, mold guy, take a look at this and view and comment on it with me, and let's make a decision right now instead of sending a file around by email. It's huge CATIA files. You're lucky if they come through email or not, right? So this just makes this a much better way of working. You'll have to work with your supplier on that and make sure that they're okay with that. But Onshape security, if you go to the LiveWorks website from a couple days ago, PTC offered a live kind of conference which had tons of materials. There's like a security briefing in there for Onshape. There's lots of, you just Google Onshape security and you're going to be able to share people what we're doing on a security side of things, and people are gobsmacked by the amount of things that we do, and they're like, okay, you guys know what you're doing, our data is secure. So it's really important to get the trust of the system. We're very transparent and open with that.
Definitely. This is probably throwing you a curveball a little bit. Do you have any native files you can show us to sort of how that process works?
Yeah, I mean, here is let's see, let's find a SolidWorks part. Actually, let's go to .prt. Actually, it'll be an SLD PRT. There are a bunch of SolidWorks parts. Let's see what this one is. I have no idea what it is, so let's see what happens. So I'm uploading a native SolidWorks part, and it is, oh, you know what? That one is not synchronized to my computer right now. Let me find something in my Google Drive because I know that one is here. So here I'm just browsing right into my Google Drive. I'll find an SLD PRT. Here we are. So I'll just bring in this foam cradle. There it is. It was uploaded successfully. There it is. It's translating it on the back end right now to the Onshape format. And once it's done, you see it right here. So that's the native SolidWorks file. And I can do other things in Onshape, with it. You notice I was able to just move that face and it grabbed all the fillet radii, and I was able to make an edit really quickly with that. So parts and assemblies, we can do that. You just need to zip up an assembly. And that's true for all the systems, Creo, NX, CATIA. But for single parts, you just upload it and go have at it.
That's awesome. Yeah, I think that's exactly what we're looking for. Regarding the assemblies, if you're sort of reusing parts across assembly lines, do the assemblies using shared parts update automatically, or sort of what's that process if you have like multiple people working on it?
Yeah, well, of course, multiple people can work on assemblies at the same time in Onshape because of the system we've built. But when you're importing data, import small sub-assemblies, build a library up. You might want to replace one for another when you import it, because when we import all of these things, we don't have a file system in Onshape, so you'll want to repoint things so that things are shared. Like if you use the same motor over and over again, and you import like 5 assemblies that use that same motor, it's going to import that motor again, but you'll just replace that motor with the one that's in your central library. And that's something we teach on our onboarding typically.
Perfect. And then just while you have that SolidWorks import up, looks like the last question we have here is, can you actually save within Onshape, save like native Creo files or native files? Just reason being, like a design firm might have data that's created or owned by clients, and they want to resave it as the native file.
We can only do that with SolidWorks right now. Maybe that'll change in the future. We update every 3 weeks based on customer request, but right now you can always export it in a format that they'll be able to import without any issue. So I get that question a lot from design consultants that work for other people that want the native file. I would double down and say, most of the time they're okay with, something neutral. If they're not okay with something neutral, you're probably going to have to use the old file-based system, right? It's up, if that's what your client wants. But if you show them what you're doing with Onshape, and politely say, hey, take a look at this Onshape document and work with me on it, I think they'd be excited. That's where most of our kind of customers
right
come
now,
from
it's SolidWorks only that you can save it natively, and not like Creo.
Yeah,
and that's just kind of something that's being added.
That's really hard, right?
Yeah,
it's a lot of work, but yeah. But you can see here the list
you
is
can always use the Onshape file.
Yeah, just share them the Onshape document, and they're gonna their minds will be blown away what you just did.
Right. Does look like there's no more questions, but I will hold for a minute. And just while we wait, I did want to mention, and Mike's mentioned it before, if you have something come up or you're interested in that trial, just visit tristar.com, our Onshape section, or simply, just give us a call, and we're more than happy to kind of help you out. I know Mike's more than happy to kind of go into more detail if there's any specific questions. So definitely just reach out to us. And with that said, we're at the top of the hour. So once again, Mike, I did want to thank you for that. That was awesome. And thank you everyone else for joining us today.
All right, glad that I was able to be here, and can't wait to work with all of you some more. It's going to be a fun journey, and thank you for having me today.
All righty. Thank you, everyone. Enjoy the rest of your week and have a safe weekend.
All right. Bye-bye, everybody.